Section 2, the night sky. Now, based on this old book I used to use years ago, the book said that if you're somewhere in an open field on a dark night, that just with your eyes, you can see about 3,000 stars. That was according to the old book, 3,000 stars. A lot of people guess a lot higher than that. And I'm sure it varies on where you're at and all that. But anyway, to give you some rough idea, you see about 3,000 stars with the naked eye. In Coral Springs, you can see 5. Why am I making that joke? Why do you not see many stars if you go out in your backyard in Coral Springs, let's say? Go ahead. Light pollution. Lights, city lights. A lot of you don't even really realize how bad this is. I mean, I just kind of chuckle to myself if I say, let's go someplace dark for astronomy night. Oh yeah, let's go to Deerfield Beach. I'm like, really? That's dark to you? Even the end of Loxahatchee. I mean, kids get out of Loxahatchee, wow, Jeter, you gotta like it here. It's really dark. I'm like, this isn't dark. This isn't dark. It's better than my backyard, but it's not that dark. I'll show you some real dark places here in just a second as we continue, okay? But light pollution is something we just have to deal with in this area. Quick vocabulary term from this section. Zenith. It's actually an Arabic word. And it just means the point directly above your head. So if we're at astronomy night and I say, look at the bright star near your zenith, you just look straight up. Wherever you're at, it doesn't matter. It means the same thing, the point right above your head. Also, at the first astronomy night, I'm going to teach you how to find the North Star. Well, the North Star, once you know how to find it, not only tells you which way is north, but it's kind of a neat little thing you can do. You can find your latitude. In the northern hemisphere, you can find your latitude very easily by finding the North Star. Let me explain. When we go out to astronomy night in August, in December, in May, it doesn't matter. The North Star, also called Polaris because it's above the pole, Polaris, the North Star is the only star that's not going to change. It's the only one that's going to be in the exact same place all year long. And it will be found 26 degrees above our horizon. Why 26 degrees? Very good. That's it. We're at 26 degrees latitude. If I was back home in Illinois, guess what? The North Star would be higher up above my horizon, and whatever latitude I'm at, 40 degrees, whatever it is, it would be 40 degrees above my horizon. Isn't that cool? Think about how important that was hundreds of years ago. Man, that was their GPS in the 1600s and the 1500s, right? They're sailing across the Atlantic. How do you know where you're at in the middle of the ocean? Well, at night you go out, you take an instrument called a sextant, and you flip it up, and you see the angle of the North Star above the horizon. So if you want to go straight across the Atlantic, let's say you're going from Spain to the New World, that's how you stay on the same latitude. You keep the North Star in the same place. Probably one of the reasons that Europeans didn't explore the southern hemisphere as much as the northern hemisphere. Because there is no South Star. There's no easy way to get your latitude in the south, and that kind of freaked them out. If they got below the equator too far and couldn't see the North Star, made them a little nervous. Now, let's get back to light pollution for just a moment here. I found this really neat, I think it's a neat map of Florida, a light pollution map. On this kind of map, black is the best. That would be the best, darkest sky possible. Then gray, then blue, green, yellow, orange, red. And the worst possible skies for astronomy would be white. Okay? Where there's lots and lots of city lights. Let's find ourselves. Let's see here. So there's Orlando. There's Tampa. Oh, here we go. South Florida. There we go. The worst possible location imaginable to do astronomy. That's where we're at. And unfortunately, just popping over to Deerfield or popping out to Lox doesn't really get us out of that light pollution. Now, there are places I know of, at least once this year, maybe for a meteor shower, we'll pop out at least into the orange. There's another place I know that's kind of on the border, probably in the yellow. Okay? And you can see there is a place out here, or down in the Keys, you can go to some places that are blue. But that's what we have to do here if we want a truly dark sky, unfortunately. Okay. Anyway, let me give you an idea of how much light pollution affects a picture. Here's a picture I took from my house in Coral Springs. I don't know if you can even see it. 1, 2, 3, 4. There are about 5 stars there. They form a cross. It's called the Northern Cross. This is the same patch of sky with the same camera, the same exposure time, everything exactly the same out in probably like the orange or yellow area. Same exact picture. That's how different it is. So, and you can see the Northern Cross right there. Even a little bit of the Milky Way. And by the way, that's how I judge if I'm someplace really dark. If I can see the Milky Way, then I know I'm someplace pretty dark. You can't see the Milky Way from Locks, for example. One of my students, Blake Porter, graduated a few years ago. He sent me this. He's going to school in Massachusetts, in Boston, but he went out in the countryside. He was really good with the photography. Look at his picture here. They're nice, huh? Of the Milky Way. Yeah, thanks for showing me up, Blake. Anyway, it's pretty awesome. And hopefully some of you, if you're on a photography team, you can learn how to take pictures like that. Let me just throw something out there. I've been in the habit lately of taking the students sometimes to some places, you know, that are really, really dark and doing some astrophotography. I have an idea for this year. What would you think about the Grand Canyon? I'm going to announce this at Astronomy Club tomorrow after school. I'll get you a price on it. This will be over spring break. We leave around March 21st or so. We'll be gone for a week. That's what I'm thinking for this year. We go to the Southwest. And we've had some epic astronomy nights. We had astronomy night on Mount Verde in Costa Rica, also on the beach in Costa Rica. And we did have astronomy night in Peru. That was epic. We were so far up in the mountains. We were staying at some dude's like ranch, sort of. I mean, I don't know who this guy was. I'm glad he wasn't a serial killer. This wasn't part of the tour. But anyway, we're just staying at this guy's camp or whatever. He had he built a concrete wall to keep out the jaguars. Yeah, it was great. But anyway, that was remote. But anyway, let's talk some more about the sky here. Ancient people made pictures in the sky, just like we would look at a cloud and imagine some picture in the clouds, right? Now let's face it, what else did they have to do? You know? They'd go out, that was their entertainment, looking at the sky, thinking up pictures, and pictures led to stories, what we now call mythology. And it's amazing, of course, different cultures around the world are not going to come up with the same pictures and the same stories. So every different culture, I mean, that's why there is, for example, a Chinese zodiac. Totally different than the zodiac you know. Because they saw different pictures than the Westerners did. Even something like the Big Dipper, and by the way, the Big Dipper is not a constellation. It is part of a constellation called Ursa Major. Big Dipper, because it does form a picture, we actually call it an asterism, if you want to know the word for it. An asterism is kind of like picture-in-picture on a TV. But anyway, the Big Dipper, maybe the most famous asterism in the sky, you would think that every culture would call it a dipper, right? Looks like a handle and everything. Well, in parts of Europe, it was called the plow. So even the dipper wasn't the same all over the world. And of course, I mean, I don't know if you're familiar with them, but the constellations are insane. I mean, I don't know where they came from, a lot of them. We'll look at them today and you'll see like 1, 2, 3 stars, and it'll be, you know, the chariot race. Right? Not always sure, you know, what they were smoking. But anyway, came up with some interesting ones. Look at this. What is this asterism right here? Orion's Belt. Orion's Belt. It's part of the constellation Orion. Those stars, nowhere close to each other. They're hundreds of light years away from it. It looks like they're right lined up in the sky, right beside each other, but they're not at all. Constellation stars are almost never physically close to each other. They look like it, but it's an illusion. You can't see depth in space. You're just looking up in a field and you think those stars are together, and they're not. There are stars that are close together. We call those clusters. All right? But most constellation stars are nowhere close to each other. The Big Dipper is kind of an exception. The Big Dipper stars were born together, and they're still actually physically pretty close together. But like Orion, I'm going to show you in a second, totally different. Let me show you this picture very quickly here. I don't know if you recognize it. We have Mount Rushmore, and here's the Big Dipper. A couple cool things you can do with the Big Dipper. Just a couple basic sky things you can do. There's a saying that goes back hundreds of years. You follow the arc of the handle, you arc to Arcturus. Very bright orangish star in the springtime sky. Arc to Arcturus. Something more important than that. The last two stars of the Dipper, like where you would pour something out, those two stars roughly point towards the North Star. That's how you find the North Star. I'll show you at astronomy night where it's at. That's how you can find the North Star. If you can find the Big Dipper, which is really easy, you can follow those two and find the North Star. Now the North Star, look at this. It's part of another asterism. 1, 2, 3. 1, 2, 3, 4. Guess what that's called? The Little Dipper. So the North Star is the tail end of the Little Dipper, which is part of the constellation Ursa Minor, the Little Bear. A couple things you can do there with the Big Dipper. Okay, I'm going to skip some stuff here. There is Orion, the Hunter, probably my favorite constellation of all, and you'll find out why during the year, all kinds of interesting stuff. In Orion, I'm pretty sure when you look at Orion like that, I'm pretty sure this is what you see. All right, everybody just picture that in your mind? Exactly, right? I mean, what else would you think of when you saw those stars? Except a guy holding a club and a dead animal. So anyway, that is Orion. But my point here is, look at this. We look at the belt stars. Look at their actual location. 1, 2, 3. Look at that. The middle star, much, much farther away than the other two stars. Look at the scale. From here to here is 1,000 light years. So it is hundreds of light years beyond those other stars. Even those two stars are pretty far apart. They're probably 100 or 200 light years apart from each other. But it's an illusion. Hey, by the way, what does it tell you about this star? If it looks like it's the same as these, but it's actually much farther away, what does it tell you about it? It's really bright. It's really bright because it looks the same as the others, even though it's much farther away. It's all an illusion. All right. About 100 years ago, astronomers got together. Different cultures had different constellations. And astronomers got together and said, look, we need to kind of solidify this and make it to where every astronomer around the world is going to use the same. We need some uniformity here. So they had a little conference, and they figured out the exact number of constellations in the sky. Does anybody know that number? How many constellations are there?
400.
Nope, less than that.
40.
More than that. I'll give you a hint. You have an advantage if you play piano.
122.
88 is correct. 88. That's all right. There are exactly 88 constellations. Now, if I took you out tonight, even if I took you to the middle of the Everglades, I could not show you 88 constellations. First of all, because some of them are only out like in the winter time that we could see. And secondly, there are some in the southern hemisphere that we never see. We could go out every night of the year and never see them here in the northern hemisphere. But altogether, there are 88. And every star has to be in one and only one constellation. Now, I like to think of constellations kind of like states. We divide America into 50 states. It's a geographic region. Same thing with constellations. And like that, for example, if you ask, where are you from? I'm from Lake City. Oh, what state is that in? Well, we're in Florida most of the time. Sometimes in the spring we like to be part of Georgia. No, you don't get to do that. You're in one state or another. And the same thing with the stars. They are only in one constellation or another, and they all have their home constellation. This idea has been around for thousands of years, and there's just no better way to divide up the sky. That's it. It's just the best way to do it. And you'll see how we use that in just a moment. Now, some individual stars of note. We already mentioned Polaris, the North Star. What is the brightest star in the night sky? Anybody know the brightest star in the night sky? Nope, that's a constellation. But it's actually where the star is. So you're, what's that? Nope. Good guess. Not Betelgeuse. I am serious. What is the brightest star in the night? I'm just teasing you. Yes, Sirius is correct. It's Sirius. Somebody mentioned Betelgeuse. That's in the top 10. That's like 9 or 10. See, that's a good one. Yeah. Now, the next chapter we get into the history of astronomy, and I'll talk more about this. But for example, marking yearly events. The ancient Egyptians, Sirius was incredibly important to them. Because just by coincidence, the time of year when they would first see Sirius happened to be the time of year when the Nile would flood. And they would have water for their crops. That was their New Year's. When they would see Sirius, it was party time because they knew they were going to get water for their crops that year. So that's an example of an individual star being very important historically. And we'll get into more of the history later. For today, though, let's talk about how stars get their names. Now, just like every animal has a genus and a species, for example, we have scientific names for every star. Even Polaris and Sirius have scientific names. We don't like to use them because they kind of have these nicknames, these common names that we use. But they do have scientific names. Here's what I want you to write down for an example. It's one that we mentioned yesterday. Alpha Centauri. Alpha, A-L-P-H-A. And Centauri is C-E-N-T-A-U-R-I. What do you remember about Alpha Centauri from yesterday?
It's the closest star.
Closest star. It's our next door neighbor star. Right? The closest star other than the sun. What do you think the alpha in Alpha Centauri means? First, in what respect? Brightness. We're going to measure the brightness of stars with Greek letters. The brightest star in its area gets to be called alpha. Then what? Beta. B-E-T-A. Beta. Then what? Gamma. G-A-M-M-A. Then what? Delta. That's as far as I'm going to go. Alpha, beta, gamma, delta. But just so you know, it goes beyond through all the Greek letters, and then they get into other letters and numbers and stuff. But that's how they do it, and it's based on the constellation. There's a constellation called Centaurus, and so Alpha Centauri is the brightest star in its constellation. I like to, again, use an example like with states and cities. I'm from Illinois, so I could scientifically, if I did it this way, I could call Chicago Alpha Illinois. Okay, it is by far the most populous city in Illinois. But, check this out. You have to be careful. If you just say, well, I guess an alpha star is really bright. But you have to be careful. Check this out. This is a very ancient constellation. Anybody know what it is? If you were born in February, you might know. Close. You're close. This would be probably, I think this is late January, most of February. Anyway, it's Pisces. Now, Pisces is usually depicted as two fish jumping out of the water. But here's the thing about Pisces. Very ancient constellation. It's cool because it's in the zodiac and stuff. But it has no bright stars. There are no bright stars in Pisces whatsoever. Doesn't matter. The brightest of those, I've never even heard of this star, but it gets to be the alpha star. Does that make sense? Let me think here. Going back to the state analogy, it would be like, if you think of major cities in the United States, you're probably not going to immediately think of Little Rock. Right? But it is the capital of Arkansas, and it's the biggest city of Arkansas, so it would get to be the alpha star in Arkansas, even though it's not a big city. Does that make sense? Or, on the other extreme, what would be the alpha city in California? Los Angeles. But that means that San Diego, we'd have to call that, Beta Californis or something. But San Diego is one of the top 10 cities in America in population. It would be the largest city in almost any other state. But guess what? In California, it would still have to be Beta. Got it? I'll test you out on this tomorrow. for today, guys. Thanks for listening. Any questions?